Hello guys, welcome to a super awesome, exciting installment of AP Cal. We're going to be doing this pretty wicked quiz here, AP Practical Exam Part 1. So right now it's spring break, and hey, spring break 2019, what's up? I hope you guys are having a good time, and let's do a little bit of calculus along the way, because it could be a little bit of fun. All right, let's get started here, guys. Yeah, don't worry about the 4:02 a.m. I just got my little Red Bull here, and we're going to just hit this up. All right, let's go. Sorry, I had to take a swig. All right, here we go. Problem 1. Give the values of a and b for the function to be continuous at both 1 and 2. So if you want to be continuous at 1, so that means that this equation here, I'm going to call that equation 1, equation 2, and equation 3. If you want to be continuous at x equals 1, 1 and 2 must be the same y value. So that means I'm going to insert a 1. So here's equation 1. Not to be confused for x equals 1. I'm going to plug in a 1 for x. So I have a minus b better equal negative 6. That's a y value, so it better equal that. All right, here's equation 2. At x equals 2, equation 2 and 3 better be the same. So here we go. Let's see. Negative 6 times 2 is a negative 12. And that better equal, let's see, 2 squared is 4. So that better equal 4b minus a. So what I would do now, guys, is I would isolate one of the letters. The letter that I'm tempted to isolate is a here. I'm going to move a to the left. I'm going to move the negative 12 to the right. So this is from equation 2. So now I have a equals, let's see, 4b plus 12. And now that I have that a equals 4b plus 12, I'm going to plug that in right here. So I'm going to have 4b plus 12 minus b equals negative 6. So 4b minus b is a 3b. And I'm going to move the 12 to the other side, minus 12 minus 12. So 3b equals, what's that, negative 18. Divide by 3. Divide by 3. So b equals negative 6. Now that I know that b is negative 6, it looks like these three have it. Out, out. So plug this back in right there. So a equals 4 times negative 6 plus 12. So let's see what we get. Negative 24 plus 12. So I get a negative 12. So here we go. Let's see. Yep, I think we're right. Let's keep going. Evaluate the limit as x approaches 3 from the right hand side, guys. So that means from the right. So this is x less than, so we're not going to be looking at that one. We're looking at this one, x greater than. So if I approach 3 from the right, I'm plugging a 3 in there. 3 squared minus 3. So this is the y value that I'm converging at, or that I'm approaching. 3 squared is 9. 9 minus 3 is 6. So it's 6. Go to the next one. Evaluate the limit. Yes, you could use a property cosine a plus b minus 5 cosine of a. But you got to recognize this, guys. That looks like the derivative. This looks like this. F of c plus h minus f of c all over h. Usually it's, so there it is. That's the derivative f prime of c. Usually they have f prime of x and they have x plus h minus f of x or whatnot. But there it is. It's the same thing. So it's a derivative evaluated at pi over 4. So the derivative of what function? The derivative of 5 cosine x. How do you know that? That it's x? Well, all this is your x. That's like your x right there, f of c, see? So you're at... Sorry, guys. So the value that you're evaluating at is at pi over 4. So here we go. The derivative, negative 5 sine x. I hope I didn't do any mistakes. It doesn't look like it. Negative 5, and then sine of pi over 4 is square root of 2 over 2. So negative 5 over 2 with a square root of 2 on the side. Let's go to the next one. Give the y-intercept of the normal line to the graph of f at the point a comma f of a, given that a is -2. So -2 comma f of -2. That's your y value. And f of x is that. All right, what I would do first, distribute that stuff. So let's see, 2x squared plus 2x. Let's see, give the y-intercept of the normal line. So they want the y-intercept of the normal line, so I'm going to take the derivative. 2 times 2 is 4, so 4x plus 2. I'm going to plug in a -2. I know this is not normal, but this is my tangent slope. So 4 times -2 plus 2, -8 plus 2. All right, so that's my tangent slope. So how's my tangent line and normal line related? Opposite reciprocal. So my normal slope, remember that normal and tangent, they cross each other and form right angles. So your normal slope is a positive 1/6. I still need a y value. I probably should have gotten it right here, guys, so my bad. Let's see what that y value is. F of -2 equals -2 squared is 4. 4 times 2 is 8. And 2 times -2 is -4. So that gives you 4. So let's see, I'm going to draw my tangent line, or write my tangent line equation here. So I'm going to write y minus 4 equals 1/6 x plus 2. Distribute. When you distribute, you get, let's see, 1 minus 4 equals 1/6x. 2 goes into 6 3 times, so plus 1/3. Let me know if I made any mistakes there. Plus 4, and I'm going to write it down here, guys. Y equals 1/6x, 4, 3, 12, 13, plus 13 over 3. There it is. So they wanted the y-intercept. So the y-intercept happens when you cross the y-axis. That means the x value is 0. So this is the number we're looking for, and there it is right there. Cool? Cool. Let me make sure that this thing's recording, because I can't tell. I can't tell the way it looks right now. Yeah, it is. I think. Yep, okay. Let's continue. Sorry, guys. Sorry. Okay. Given the derivative and f of 0 equals 2, what is f of -4? So think of this as velocity. Think of this as initial position. And think of this as what's the position of -4. So f of -4 equals f of 0 plus the displacement of your velocity. So from 0 to -4 of square root x plus 4 minus 3 dx. I'm going to go ahead and rewrite it, guys. See, I have a -4 on the top and a 0 on the bottom. I'm going to rewrite it. So I'm going to write it like this. All this is part of your integral there. So here we go. So f of 0 was 2 minus, let's see, antiderivative of x plus 4. Well, that's the same thing as saying x plus 4 to the half. And as long as it's power 1 in the inside, then you're good. So let's add 1 to that exponent. So x plus 4 to the 3/2 divided by 3/2. So put a 2/3 in the front. And if you take the derivative, you'll see that you'll get the same expression. That cancels out with that. When you multiply, subtract 1, you get a half. So there it is. Times 1 if you want to be specific with chain rule. Antiderivative of 3 minus 3x. All that is being evaluated from -4 to 0. Maybe I should have left it how it originally was. No big deal. All right, here we go. So 2 minus, and then here's my bracket, upper minus lower. So I'm going to do the 0 first. So 0 plus 4 is 4. The square root of 4 is 2. 2 to the third is 8. So 2/3 times 8 minus 0. So that's what I get from the top one, the 0. Minus, now I'm plugging in a -4. Negative 4 plus 4 is 0. 0 to anything is 0. Minus 3 times negative 4 is a 12. So let's see what we have here. 2, oh, how did that happen? 2, let's see, minus 8 times 2 is 16 over 3 minus 12. Common denominator, 12 times 3, 12, 24, 36 over 3. 16 minus 36, 26, 36. I think that's negative 20, right? So 2 minus, let's see, negative 20 over 3. Excuse me. Turn that 2 into 6 over 2. Oops, no, sorry. 6 over 3. Plus 20 over 3. And we got 26 over 3. Yay. There it is. All right, here we go. This guy here. So what they want you to do first is take the derivative of the inside, and then whatever you get here, multiply by 2 to the to 2x, and then take the derivative of all that. So let's do this first. Let's do this guy right here. So the derivative of that, it looks like 1 minus the derivative of sine is cosine, 5 cosine pi over 2 x squared, and then chain rule times, let's see, 2 pi over 2, so pi x. So let's put this together. 1 minus 5 pi x, pi over 1 minus 5 pi x cosine pi over 2x squared. It is going to get kind of nasty because now we got to multiply all this by 2 e to the 2x. So let's see what we get. When you do that, we have 2e to the 2x minus 5 times 2 is 10 pi x e to the 2x cosine pi over 2x squared. Yeah, it's bad. All right, and now they want us to take the derivative of that. So let's try and do that. So I'm gonna, let's see. So we're taking the derivative of that. Let's see if we can do it. 2e to the 2x, that's just 4e to the 2x. 2e to the 2x times 2. Now this part here, we're gonna do product rule. But within the product rule, there's going to be another product rule, as you can see. So product within product. So there's a product rule within the product again right there. So yeah, it's going to get nasty, guys. So here we go. So I'm going to write minus first 10 pi x times rid of the second. And I'm going to count this as the first again. So I'm going to go first e to the 2x times rid of the second. So I'm going to write negative sine pi over 2x squared times pi x plus second cosine pi over 2x squared times rid of the first. So that is times 2 e to the 2x, times 2e to the 2x. All right, do we take care of all that? Let's see. First times rid of the second, plus second times rid of the first. All right, we're not done yet. Plus second times derivative of the first. Derivative of the first is 10 pi. All right, let's see if we did it right. First times derivative of the second, which is all this mumbo jumbo, plus second times derivative of the first. Yeah, looks correct to me. Plug in a 0. So let's see what happens. If you plug in a 0, e to the 0 is 1, so 1 times 4 is 4. And then I see a 0 here. So if this is 0, then all this cancels out. But I still have this guy here. If I plug in a 0 here, cosine of 0 is 1. And e to the 0 is 1. So this is 1 times 10 pi. So I see 10 pi. So 4 minus 10 pi. Oh, that was tough. Sorry, guys. It was pretty ugly. All right, here we go. So the position of the particle moving along the line is given by S of t equals that mumbo jumbo between 0 and 4. For what values of t is the speed of the particle smallest? Okay, they're saying speed, not velocity. So we got to understand that the smallest possible speed is 0. And they want the t values. So I'm going to take a derivative equal to velocity to 0. And those are that's when the speed is the smallest. You cannot have a negative speed, guys. Speed is absolute value of velocity. Speed is absolute value of velocity. So the smallest speed possible is 0. So here we go. V of t equals 3t squared minus 33t plus 72. It looks like a 3 goes into all of these. So I'm going to factor out a 3. So I have t squared minus 11t plus, let's see, 72 and 3, 24. That took longer than necessary. All right, I'm going to equal that to 0, and let's factor it out. 3, and then two numbers that multiply to give you 24, but add up to 11. What's that? 8 and 3, 8, 9, 10, 11. Yep. So t minus 8, t minus 3. So I get two values. T equals 3, t equals 8. And they want you to choose 8. So I'm sorry, someone got this one wrong. They want you to choose 8, but look at the values here between 0 and 4. So just 3. Nope. All right, let's go to the next one. What is the exponent of the point of inflection for the given function? Point of inflection is where the second derivative changes signs, guys. So we got to do that. So second derivatives, here we go. So I'm going to write f prime of x equals 4 times 3 is 12, so 12x squared minus 2x minus 2. That's the first derivative. Take another derivative, so 24x minus 2. And that definitely changes signs. So what are the change signs? Well, just equal to 0. 24x equals 2 divided by 24 divided by 24. X equals 1 over 12. It changes signs at 112. Get these right. All right, the function g is differentiable, and the tangent line to the graph of y equals g of x at x equals negative 4 is blah. Let f of x equals all that stuff. Give f prime a negative 4. So they're giving you a lot of information, guys. So they're telling you, here's what they're telling you. G prime of negative 4 must equal 4 because this is my tangent slope. It's the 4x minus 5. That's your tangent line. They also give you g of negative 4. You don't know they do, but they do. Remember, every time you have a tangent line to a curve, that right there, that x comma y, they share that point. The tangent and the curve share that coordinate. So if this is my tangent line, plug in a negative 4, and that will be your y value. 4 times negative 4 minus 5. I hope that made sense to you guys. If it didn't, rewind it and see what I just said. The tangent line and slope, and your tangent line and coordinate, I'm saying everything wrong. Your tangent line and curve share that point. And I hope that's what I said. I'll rewind it just in case. 4 times 4, negative 4, negative 16, negative 16 minus 5, negative 21. So my point is negative 4, negative 21. All right, let's take a derivative. F of x is negative 5g of x, that's a g, plus 4x plus 2. So f prime of x is equal to negative 5g prime of x. Oh, it looks like you don't need your g of x anyways. Plus 4. So I'm going to plug in negative 5 times, I'm going to plug in 4. Plus 4. Negative 5 times 4 is a negative 20. And when I add 4 to it, I get a negative 16. All right, let's see here. The graph of f prime, the derivative of f is shown below. What value of x does the graph of f(x) change from increasing to decreasing? All right, if f prime is positive, this means f is increasing. If f prime is negative, that means f is decreasing. I have f prime here, guys. They're telling me this is the graph of f prime. What value of x does f of x change from increasing to decreasing? So I'm looking where it goes from positive to negative. It looks like it happens right there. And that looks like it's, let's see, 1, 2, it looks like it's a perfect 3. So there it is, 3. This person got it right. Good job. All right, what's the following is true about the function blah? All right, so the best way to do this, this is non-calculator, guys. The best way to do this is you're just going to have to go through the motions here. So let's figure it out. Let's take a derivative here. F prime of x equals 9x squared minus 10x. I'm going to get my critical numbers where this equals 0. I don't see any mistakes at the moment. 3, 3, 9. No, everything looks good. I'm going to factor out an x. So I'm going to have 9x minus 10. And I get two critical numbers. I get 0 and 10 over 9. So I'm going to do my little number line. I'm going to call that f prime. I'm going to put 0. And 10 over 9 is a number just slightly larger than 1. Because 9 over 9 is 1. And I'm just going to put numbers, see if I change signs here. So if I put a negative 1, let's see. Negative 1, 9 times negative 1 is negative 9. Negative 9 minus 10 is more negative. Negative times the negative is a positive. You just care about the output. You don't care about the actual number. If I put a number like a half, 9 times a half, that's like, I don't know, 9 over 2, right? 9 over 2 minus 10, that's going to be a negative number. Positive times a negative number. Because 9 over 2 is a smaller number than 10. So when I subtract 10, you have a negative number, right? All right. It's like 4.5 minus 10, right? All right, next, a number larger than 1, so like 2. 9 times 2 is 18. 18 minus 10 is going to be positive, and 2 is positive. So let's see, for sure, I have, that's a local max, and then that's a local min. Understand that this graph is increasing from negative infinity to 0, decreases for a little bit, and then it increases again. So this has no global max or min. So I'm going to look for something that says 2 relative extrema. This one says one local maximum, and maybe, let's see, 2 relative extrema, maybe. 2 local minimum, no. 3 relative extrema, no. 1 local maximum, maybe. So here, we got the 3 maybes. Let's take another derivative to see what's up with points of inflection. F prime prime equals the derivative of 9x squared is 18x, and the derivative of 10x is minus 10. So it looks like I just have 1 point of inflection because this only changes signs 1 time. You can stop there, but I'm going to go ahead and continue it if you wanted to know. X equals, let's see, 2 goes into 10 5 times. So this is where your point of inflection is at. Point of inflection. I would not use this abbreviation or this acronym, but whatever. So 1 point of inflection. 1 point of inflection. It looks like it's that one. 2 points of inflection, no. Let's see. 2 points of inflection, no. It's letter A. Let's go to the next one. The function definitions are differentiable functions. Use the information rule to find h prime of 4. So here they're just testing to see if you know the quotient rule, guys. They're telling you that h of x is equal to f of x divided by g of x. So here we go. H prime of x is equal to bottom times derivative of the top minus top times derivative of the bottom, all over bottom squared. Now some of you guys know a little trick: low d high minus high d low over low low. That's fine, no big deal. You can sing your song. Let's see, h prime of 4. So let's plug it in. So g of 4. Where are you? G of 4. 3. F prime of 4 is 3 minus f of 4 is negative 4, and then g prime of 4 is negative 3 all over g of 4, which is 3. So we get 3 times 3 is 9, 4 times 3 is 12, over 9. 9 minus 12, so 11, 12, so negative 3 over 9, so negative 1/3. Negative 1/3. And that's it, guys. Let's keep going. The graph of y equals f prime of x is shown below. Give the value of x for where f has a maximum on interval negative 3 to 3. Okay, maximum, this is f prime. So I have a max where f prime changes from positive to negative. That's where f has a max, because your f is changing from increasing to decreasing. So you have a max at 1. And this person got it right. Yep. All right, let's keep going. Find the equation of the tangent line to the curve at the point 2, 1. All right, so you already have a point. All you need now is a slope. So we're going to take the derivative of this. So you're going to have to do implicit here. Let me format it here. All right, here we go. I'm taking the derivative of everything with respect to x. So the derivative of 3x squared is 6x plus the derivative of 3y squared is 6y dy dx equals product rule right there. First times derivative of the second plus second times derivative of the first. I'm going to put the 3 in the front. Minus 1. I don't see any mistakes. It turns to algebra now. Move the dy dx's to the left. Everything else moves to the right. So I'm going to have 6y dy dx minus 3x dy dx equals, let's see, 3y minus 6x minus 1. Factor out of dy dx and divide. So you have 3y minus 6x minus 1 divided by 6y minus 3x. There's nothing to cancel out, so don't cancel anything out. Plug in your 2 and 1. So dy dx evaluated at 2 comma negative 1 is, let's see, 3 times negative 1 is negative 3. Minus 6 times 2 is 12. Minus 1 all over 6 times negative 1 is negative 6. And then 3 times 2 is 6 again. So let's see what we have here. 12, 13, 14, 15, 16, so negative 16 over negative 12. So that reduces to, let's see, 8 over 6, which is 4 over 3. So there's my slope. So here it is, y plus 1 equals 4/3 x minus 2. Notice that, look how they have it written. I'm going to multiply everything by 3. So I have 3y plus 3 equals 4x minus 2. Distribute. So 3y plus 3 equals 4x minus 8. Move the 4x to the left. Move the 3 to the right. 3y minus 4x equals, let's see, 8, 9, 10, 11. Negative 11. So now let's look for that. 3y minus 4x equals negative 11. Alright guys, here's this one. Before you tackle this, simplify most of that right there. You can see that it simplifies. If you can't see it, let's go ahead and show you. Tan x is sine over cosine. And then I'm multiplying by cosine x. And then cosecant is 1 over sine. So look, cosines cancel out, sines cancel out. See, so you're just left with 4. So what you're really integrating is 5x sine x squared plus 4 dx. That's what you're really integrating. Now, to integrate this here, you're going to have to do u sub. So let's split it up into 2 integrals, guys. 5x sine x squared plus integral, I'll put a dx there so we can indicate the n there. 4 dx. All right, u sub. So I'm going to write u equals x squared. du equals 2x dx. I'm going to move the 5 to the outside. So here I am erasing the 5, putting it outside. Put a 2x dx in there, balance it out by putting a 2 on the outside there. So there we go. Now we're good. 5/2 integral sine u du. So the antiderivative of that, let's see, 5/2, antiderivative of sine u is a negative cosine u. So negative cosine. Now instead of writing the letter u, since I have no limits, I'm going to plug back what u is. U is x squared. X squared. Now we're not done. Don't forget about this lonely 4 over here. So antiderivative of 4 is just 4x. And then you put plus c. So that is right there. All right, let's go to the next one, guys. This looks like another U sub. I'm letting this give me hints. I bet you it's an ln graph. I mean, I bet you when we do the antiderivative it's going to be ln because that's all there is. That's the only option. So I'm going to say that u equals 4 plus the square root of x. So I'm going to rewrite it. U equals 4 plus x to the half. So when you take the derivative of this, you get 1/2 x to the negative 1/2 dx. Now relax. Let's rewrite it. 1/2 square root of x dx. And OMG, look, you have it right there. That's your du. So I have 1/u du. And lo and behold, the antiderivative of 1/u is ln. So ln, absolute value of u, plus c. There was nothing to balance because this took care of it. The 1/2 square root of x dx. And since we're only talking about, since it's square root, it's talking about only positive expressions. So it's okay to take out the absolute value on it. U was 4 plus square root of x plus c. So let's look for that. Where are you? ln 4 plus square root of x plus c. There you go. Go to the next one. What if the area is region bounded by the curve? All right, so x minus 5 is just a parabola. Move 5 times to the right. So it looks something like this. Let's see, 0, 25. So this is like, it's not drawn to scale, but whatever. And then y equals 16 is just a horizontal line. 16. And they want this region. So first, we need to find where they intersect. So we're going to write 16 equals x minus 5, close it squared, square root, plus minus 4 equals x minus 5. I'm going to rewrite it, guys, because I like to have the x minus 5 on the left-hand side. And then I'm going to move the 5. So 5 plus minus 4. So one of them is 5 minus 4, which is 1, and the other one is 5 plus 4, which is 9. So this is a 1, this is a 9. So now we're going to integrate 1 to 9, upper minus lower. So 16 minus parenthesis x minus 5, close it squared dx. And you just take the antiderivative and plug in the 9 and plug in a 1. I think you guys can take that one, guys. So can I go on to the next one? Yeah? Okay. All right. The function f of x is invertible. So what that means is that it has an inverse. You're not going to try and find the inverse of this, guys, because you have a linear component and then you have something that's going up and down. So don't even try it. So what you're going to do, they want the derivative of 5 power over 2. That is a y value in original. So I'm looking at this and I'm saying, okay, what x value can I put in there that I will get a 5 power over 2 as a y value? And I see a 5 there, so it's obvious to me that it has to be, let's see, it has to be power over 2, because 5 times power over 2 is 5 power over 2. So, Chavez, I have no idea what you're talking about. Let me show you guys. 5 times power over 2 plus cosine of power over 2. Cosine of power over 2 is 0. So notice when I plug in a power over 2, I get a 5 power over 2. Well, 5 power over 2, that's what they want there. And this is a y value on the original, see, because they want the inverse. So what I'm going to do, remember the property about inverse functions, guys. If you have a function that looks like this, then that means your inverse looks like that. So if I have a point here, a comma b, so that point is right here as b comma a. So if I tell you that f prime of a is equal to, I don't know, let's just make up a number 4, then that means that the inverse function, I'm going to call this the inverse function. So my inverse, the derivative of my inverse evaluated at b has to be 1/4. Just take the reciprocal. It has to be 1/4. You just take the reciprocal. Chavez, I don't understand. I'm a robot. Help me understand. Well, remember, guys, the slope is the change in y over the change in x. And when you're finding the inverse function, you switch your x and y, really, because that is y equals x. So you switch your x and y and you find your new function. So that means your new slope for the inverse function has to be change in x over change in y. So that just means reciprocal. All that means is reciprocal, guys. So if this slope is 4, the slope of the inverse line has to be 1/4. So Chavez, what does it mean in terms of calculus, in terms of this problem? That means I'm going to find the derivative of this function, and I'm going to plug in a pi over 2, and whatever output I get, I'm just going to take the reciprocal. So here we go. F prime of x is equal to 5, and the derivative of cosine is a negative sign, so minus sine x. Now I'm going to plug in a pi over 2. F prime of pi over 2 equals 5 minus sine of pi over 2 is 1, so I get a 4. Oh, that's by pure coincidence, guys. Maybe these answer choices maybe influence me. All right, so since I have a slope of 4, that means my inverse slope must be 1/4. And that's it. All right. Average rate of change. Average rate of change. To me, that just looks like, be careful, it says average rate, not value. So this just looks like an algebra 2 problem to me, guys. F of 2 minus f of negative 2 divided by the difference between 2 and negative 2, so it's 4. So I think you guys can do that one. I'm going to go ahead and continue. All right, determine the value of f prime of 3. All right, first let's take the derivative. Check that you have an x on the top and a constant on the bottom. I do. So f prime of x is equal to 1 over x squared plus 9. And now I'm going to plug in a 3. F prime of 3 is equal to 1 over 3 squared plus 9. So 1 over 9 plus 9, so 1 over 18. The graph of y equals f prime is shown below. Give the largest value of x where the graph has a point of inflection. All right, I have a point of inflection where the second derivative changes signs. That means where f prime goes from increasing to decreasing or vice versa. So let's see, it says give the largest value of x. So it looks like this one's the largest value of x because the more right you go, the larger the x value. See, I went from decreasing to increasing. F prime went from decreasing to increasing. So it looks like it's 1. And this person got it right. So let's see if it's 1 here. There you go. All right, which of the following is the slope field for the given differential function? All right, before I even look at the slope fields, it's x squared, guys, meaning I don't want to see any negative slopes. So that's one hint. It's only affected by y. That one's out right off the bat. I see negative slopes all over the place. Let's see. This one's out again. I see negative slopes. Let's see. That one here is out again. I see negative slopes right here. Maybe. And maybe. All right. So let's see which one it is. When x is 0, the slope is 0. So that means the y-axis. On the y-axis, yeah, look, slopes are 0 all the time. And on the other one, nope. So it's this one right here. Another hint, guys, notice this looks like x cubed. And sure enough, if you do the antiderivative of this function, that is going to be a 1/3 x cubed or an x cubed function. So there's your hint. All right, let's go to the next one. This is probably one of the tougher ones here. Let's get this one out of the way here. So let's see. Change the, f prime and f, change it to dy dx. So 4 dy dx plus 5y equals 0. Move the 5y to the right. 4 dy dx equals a negative 5y. Divide by y times dx. So I'm going to have 4 over y dy equals negative 5 dx. I don't see any mistakes. Let's go ahead and integrate those. So I see, let's see what I see. 4 ln, absolute value of y, equals negative 5x plus c. So now what I'm going to do is I'm going to divide by 4. That's a 4. So ln absolute value of y equals a negative 5/4 x plus c, because c divided by a constant divided by 4 is still a constant. I'm going to do e and e. So I have absolute value of y equals e to the negative 5 fourths x plus c. But I can rewrite this. I'm going to write it as y, guys, and I'll explain in a little bit. I'm going to rewrite this as c e to the negative 5 fourths x. Now, the reason I was able to do that is because right here, that is e to the negative 5 fourths x times e to the c. Now, e to the c is just some constant. It's just some constant. So here's my constant, and I took out the absolute values because my condition is going to determine whether it's y is a positive or y is a negative. So I have this here, 2, 4. So I'm plugging a 2 for x, and I'll put a 4 for y. So 4 equals CE. Let's see, if I plug in a 2, so 2 goes into 4 twice, so negative 5 halves. So I'm going to divide e to the negative 5 halves, and that's going to get me my c. So c equals 4 e to the 5 halves. Chavez, why did you turn it to a positive? Because when I divide by negative, it's down here, guys. So that e to the negative 5 halves, you can bring it up, and there it is. So that's what c is. All right, so now that I know that c is that, here's my equation. 4e to the 5 half times e to the negative 5 fourths x. Now it looks awkward, especially when you have the same base here. So just combine them. Since you're multiplying, you can just write e to the negative 5 fourths x plus 5 halves. And let's look for that. Out e to the negative 5 fourths x plus 5 halves. Here it is. This person got it right. There it is, guys. Y equals, to make it perfect. All right, next one, calculate f prime prime. So we're going to have to do two derivatives. Before you do that, guys, move the x to the top, put a negative on the outside, 0 to x, square root t squared plus 4 dt. So f prime of x is equal to a negative square root of x squared plus 4. And now I'm going to take the second derivative. Before I do that, let me rewrite it. All right, here we go. F prime prime of x equals, bring the half to the front, and then x squared plus 4 to the negative half times 2x. The half and the 2's go away, and you have, let's see, x over negative square root x squared plus 4. So there you go. Find the volume of solid determined by rotating the given region about the x-axis. So I have a parabola here opening up in the x direction. So I have something like this. And let's see, that's just a line, y equals x minus 3. So it looks something like that. So let me erase, let me just show you the region that really matters. So it's that region that I care about. And I'm rotating this about the y-axis. So when I rotate it, I get something that looks like, okay, it's not perfect, but you know, whatever. And as you can see, you have washers. All right, so I need to figure out this point down there and this point out there. Now you can see that washers are dy. So we're going to be integrating with respect to y, guys. So 2y squared equals y plus 3. Move everything to the left. 2y squared minus y minus 3 equals 0. Let's see. 2y and y. And the 3 is going to have to go here and here. Let's make sure that everything works. 2y times 1 is 2y. 3 times y is going to be negative. It's going to be positive. Let me make sure everything's correct. 2y squared plus 2y minus 3y minus 3. Yep. So y equals negative 1. Y equals 3 over 2. So there we go. So now we're going to integrate. It's a washer. So big R squared minus little r squared, pi on the outside. Integral negative 1 to 3 over 2. The big R, distance from here to that linear line. So it's going to be y plus 3 squared minus the little r. It's this curve right here, the parabola. So I'm going to write 2y squared squared. And I think you guys can take it from there, right, guys? Just expand, just do antiderivative, y plus 3 to the third power divided by 3 minus, and this, go ahead and square this, so that's 4y to the fourth. So that's going to be 4y to the fifth over 5. I think you guys can take it. All right, determine the interval which f of x is concave down. They already gave you the second derivative. They're being nice. Let's see. Can we factor anything out? I think we can. Yeah, I think 3 goes into all of them. So let's factor out a negative 3. So if we factor out a negative 3, I'm going to get x squared plus, let's see, 2x minus 15. Let me know if I'm wrong, because I make mistakes all the time, guys. So now it looks like, I think it's factorable. Yeah, it is. Two numbers that when you multiply give you negative 15, but add up to a 2. And that is 5 and 3. So it's going to be x plus 5, x minus 3. So I have two critical numbers, negative 5 and 3. They want to know where I'm concave down. I'm going to do my little number line. I'm going to call that f prime prime. I'm going to put negative 5 there. I'm going to put 3 here. And I'm just going to choose numbers. So if I choose negative 10, this inside expression is going to be negative. That's going to be negative. But then I have a negative here. So that's negative. If I choose 0, positive and a negative, that's negative, but then I have another negative, so it's positive. If I choose 10, positive and positive, but then I have a negative, so negative. So where am I concave down? Negative infinity to negative 5, and 3 to infinity. And infinity to negative 5, and 3 to infinity. All right. Evaluate this limit. Let's see. Okay. So I don't know if you guys recognize this, but this is also the definition of a derivative if you pay real close attention to it. I know you can do L'Hopital's rule, and we haven't covered it yet, but it looks like to me, limit as x approaches c of f of c minus f of x minus f of c, all over x minus c. This is the alternate form, guys. So sine of, if I put a 5 pi in there, 5 pi times 2 is 10 pi. Sine of 10 pi is 0. So that's why you don't see it in there. Sine 2x minus 0. And then x minus 5 pi. As soon as you see a 5 pi there and a 5 pi there, and you see x and x, it's probably the alternate definition of a derivative. You could also use L'Hopital's rule, but we haven't learned that yet. We're going to learn it this week. So relax. All right, let me take another swig of my little Red Bull here. All right, here we go. So I'm going to write limit. Wait, I'm not going to write limit. I'm going to write derivative. My function is sine 2x. And I'm going to take my derivative and plug in a 5 pi. F prime of x equals, the derivative of sine 2x is cosine 2x times 2. So, let's see, 2 cosine, if I put a 5 pi in there, that becomes 10 pi. So that becomes 2 times cosine of 10 pi. If you think about the unit circle, the 2 pi's are always here, and those are always the even number. 2 pi, 4 pi, 6 pi, 8 pi, 10 pi. So cosine of 10 pi is 1. So 2 times 1 is 2. Yay. All right, is this the last one here? Yeah, this is the last one. All right, guys. Last one. Find a and b given the function has a minimum value of 8 at x equals 1. All right, so they're giving us two pieces of information. They're telling us that it's a minimum when x is 1. So that means I'm going to take the derivative which is equal to 0 when x is 1. And they're telling me that the value when x is 1 is 8. So I'm going to write 8 equals a divided by square root of 1 is 1, plus b. So there's equation 1. Equation 2. We'll take the derivative. So first, let's take the derivative. I'm going to rewrite it. A x to the negative half plus b x to the half. So here we go. So y prime is equal to negative 1/2 a x to the negative 3/2 plus 1/2 b x to the negative half. Now I know that this equals 0 when x is 1. So I'm gonna do that right now. Negative, let's see, a over 2x to the 3/2 plus 1 b over 2x to the half. I'm just rewriting it, guys. So I'm going to plug in a 1 for x. So negative a over 2 plus b over 2 equals 0. So that means times 2 everything. Negative a plus b must equal 0. So that means a equals b. If you move the a to the other side and then rewrite it with a equals b. So now that I know that a equals b, I know they have to be the same. That one's out. That one's out. That one's out. It's between 4 and 8. So how am I going to figure that out? Like this. I'm going to choose, since a equals b, I'm going to come back over here. And I'm just going to rewrite it, guys. I'm just going to rewrite it. I'm going to replace the b with an a. A equals a plus a. So a equals 2a. So that means that a equals 4 when you divide it by 2. So it's that one. Alright guys, I hope you enjoyed this video. Spring Break 2019. We did all of them. We didn't do some simple arithmetic for some of the questions. If they give you issues, let me know and we can talk about how to do the arithmetic. But we at least set it up for you guys. So I hope you liked it, guys. Hook me up with a thumbs up and leave me some comments if you have any questions or if I made mistakes. Alright, later guys. Bye. Well, now I gotta... This is awkward. Okay. Wait up. Okay, now we're good.